Okay, this is the second part of the handout, and as I explore, I discover new things. So I actually got to take a picture of the handout. So let's see if this works. I'm going to do the questions that talk about population growth and decay. And so all this stuff up here is just a bunch of just a lot of info, but hopefully that as I go through a question, I am talking about this kind of stuff up here. So I'm not going to spend a whole lot of time just going through these notes up top. So let's just go ahead and start with a question because it might make more sense. So we got a certain species of fish to be introduced into a lake, and wildlife experts estimate the population is going to grow to, and they give me this formula. And so 751 is the initial population we start off with. And this 2 is the amount of doubling. I want to be doubling the amount of fish that I started off with. And so T, the unknown in the exponent, is how long will it take it to do this? And so basically what I want to do is when I set this equation up, I want to take 751 and I'm going to go ahead and double it. And I'm basically going to say 1502 is equal to 751 times 2 to the T over 3 power. T represents how many years will it take for the number of fish in this particular lake to double. So like the previous questions that I kind of did on the last video, I need to isolate this parenthesis. So if I take and divide by 751 over here, guess what? That'll give me a 2. And so I just drop the parenthesis, 2 to the T over 3. Let's kind of run onto each other. But this takes us to the last lesson. Check out our exponents. 2 to the first equals 2 to the T over 3. Hey, same base, set your exponents equal to each other. Okay, and when you do that, you're able to solve for T. So if I solve for T, I'm going to multiply by the reciprocal, and that way 3 will cancel. So T is actually equal to 3 years. And then the next question says, how long will it take the population to reach 12,016 fish? Well, I'm kind of doing the same thing. 12,016 is equal to 751 times 2 to the T over 3 power. Well, when I divide by 751, I'm going to end up getting 16 is equal to 2 to the T over 3 power. Well, just like last lesson, I need to get bases to be the same. So if I look at 16, isn't 16 the same thing as 2 to the 4th? And then 2 to the T over 3. Same base. Set the exponents equal to each other. I'm just going to multiply both sides by 3. That way it cancels. So it's going to take 12 years for us to reach a population of 12,016. And then the second part of that question gets us into half-life. Well, the first 2 were doubling, so here I want half-life. And so if you can just assume that half-life is where I want to be, that would be my A sub T. And A naught represents what I start off with. And so I'm looking at this formula right here, and I'm trying to understand what it means. Well, A naught means, how much do I begin with? Well, they don't tell me what I begin with, but what they do tell me is how long it takes me to reach half-life. And so this 730,000 is my exponent. All right. And so what I'm going to do is like I did at the top of the page. I have an exponent of 730,000. I need to get rid of that exponent. So I'm going to take the 730,000th root. Yep, you can do that. So what I do to one side, I'm going to do the other. So that way that is going to cancel, and I need to know how much do I start off with in the beginning. A naught is the initial amount. And so when I stick this into the calculator, 730,000th root of 0.5, I get 0.99999. Okay? And so they want to know, first of all, what's A? What's the initial amount? Okay? And so that's step one of this first question. Now, part B says, okay, how much of a 3-gram sample, now I'm going to start off with 3, of aluminum-26 would be left after 4,332 years. So I'm kind of finding, we'll plug in 3. So I'm going to begin with 3, but I know that that A is representing that rate of decay, if you will. And so I'm going to take it to the 4,332 power. And just using my calculator, I'm going to get 2.987 grams. Okay, I've got a second question just like it, but now it's talking about gold, another element, and so it tells me that the half-life of gold is approximately 30.5 seconds. So it's the same kind of formula. I need to figure out what A is, and so I know that if I want to end up with half, A is I kind of misspoke a little bit earlier. It's really not my initial amount, it's my rate of decay is what it is. In a sense, it's the base that I'm using. So A to the 30.5. And so what I want to do is solve for A. So just like I did on the previous question, I'm going to take the 30.5 root of 0.5. And that's going to give me, now again, you know how Hawks is, they don't like you to round, so I would string it out several decimal places. It says, and it tells it 6 decimal places is what you're going to use it to. So 0.977530 is that amount for A. And then it says how much of a 14-gram sample, so I'm going to begin with 14 grams, and then this is my decay rate. Now, notice this is below 1. So if it's below 1, I'm decaying, so that makes sense. And it says 57 seconds. So how much of this gold 195 would be left after 57 seconds? How many grams? And so you just put that into your calculator, and you get 3.833 grams. Okay. All right. I want to get to just a clear screen to do this last question because I need to have some room to write it. So I'm going to do this last question, then I'm going to add another one on that I saw in the practice that was not on this handout. So we're doing population growth. And so in an effort to control vegetation, there were 124 rabbits. that were released into this isolated area. And it just wanted to see how many rabbits were going to populate after 2 years. And so it estimated that the 124 rabbits actually populated to 1,116 rabbits. And so the question is, assuming exponential population growth, what's going to be the population after another 6 months? And so using what I've already known, a formula that I've already done, this is my target. And remember, I started off with 124 rabbits. I need to figure out that growth rate. And T was 2. So this was A naught. This is just A, and then this is the time that I'm going to keep it in that area, and it's going to populate to 1,116. So I need to solve for A right off the bat. So doing what I did before, divide by 124, and I get 9. And taking the square root, A is 3. So that's my growth rate. So it's like growing 300%, if you will. If you think about a decimal, 3 is a decimal, it's 300%. So what they want us to do now is, after an additional 6 months. So I'm going to start off with 124, the original amount, my growth rate. And remember, I already had 2 years, but I want an additional 6 months. Well, 6 months in terms of years is 2.5. And so if I just multiply that out, that's going to give me the number of rabbits after 2.5 years. So 1,932.96, and they want me to round to the nearest rabbit, so 1,933 rabbits. Okay, I've got one last question, and it is on my notes that I uploaded into Google Classroom. But it's just called a revenue function. It's real easy. They give you the function. You just have to plug in the information. So here's the function. R of x equals x times p of x. And x stands for the number of units sold. And p of x is the price. So how much are you paying for the number of units sold? So here is the formula they give us. They tell us p of x is 31/3 to the negative x over 7. And that's kind of unusual, but you got to realize in marketing and economics, they have computer programs that figure out these models that describe sales. And so this is a model that's been derived probably from a computer program or something to describe this revenue function. Well, anyway, all they want us to do is, well, how much revenue is made if 14 units were sold? Well, all you do is stick in to the equation 14. And so using your calculator, you get this amount, 3.4444. But remember, that's p of x. This is what p of x is. So I need to go one more step and find the total revenue. So I have to multiply 14 by 3.444. And that will give me, remember money, $48.22. So that's the total revenue that is made off of 14 units that were sold. And they don't tell me what I'm selling. You know, this could be, any type of units. So that's how much money I end up making in the end. So hopefully that isn't too overwhelming. So give it a try. Look at my notes. Take notes from the lecture and see if it helps you out. And hit me on Ramon, and I'll try to answer any questions you have. Thanks.